Good evening, Ayush. Good evening, Gunjan, Komal. Please confirm if my sound is audible. Sara, Gauri, Khushi, Anshika. Okay, thank you, Komal. So we are moving to yet another episode of this algebra. And it is going to be more and more mathematical. I hope you are comfortable with equations now. There are a lot of heavy expressions, lengthier equations, a lot of calculations. And simultaneously, there are a lot of basic concepts as well. Yes, Priyanka, that's correct. So algebra समझने में difficulty आ रहा है. So as I was saying, it is becoming more and more mathematical. So if you don't continue to remain afraid of mathematics, then it is enjoyable. But simultaneously, little bit fear will also remain there. So cope up with it. We have to be accustomed to it. See, there are not only fixed type of questions, fixed type of concepts. With every new type of question, we may need to think totally different way also. So today we are going to discuss about inequalities, Gunjan, and we'll be starting with modulus part tomorrow. Fine. So for this week, that means today and tomorrow, our topic is this inequalities, which we are going to discuss today. Inequalities, we are going to discuss maxima, minima, and we also will start with that maxima or minima in quadratic expressions. Although we have discussed it in last week, but still we will discuss some more questions based on that. Maxima and minima in quadratic expressions, quadratic equations, and then inequalities, and then some more expressions. And tomorrow we shall discuss about modulus. Okay, good evening, Zinab, Vedanti, Rohit. LRDI में problem आ रही है. LRDI is also same way on the similar lines of algebra, and not only algebra, in all topics basically. See, the things which we are learning, which we are practicing a type of questions, a variety of things. But you never know, there can always be different ways of things. And in LRDI, almost in every set, you can find a totally different way, different approach. So that little bit fear factor will always remain there. So we should be comfortable with it. Sometimes you will be able to solve it. Sometimes it may take a long time, right? So don't bother. It's okay. Gungun is asking, this is totally different topic. No, it is not totally different topic. It is not totally different topic. Exactly, pura algebra. Actually, whole quant is interrelated. Lot of times we solve equations, lot of time we discuss about the numbers. So factorization, many things are there. So everything is interrelated. If you have missed the previous classes, by the way, you are having only 2 classes of quant every week. So there is enough time to revise if somehow you missed the previous week's class. Graph method of inequality आज होगा. Raghavendra, yes, we discussed about the graph part also, no, in that quadratic. So we are going to start with the maximum minimum quadratic only, and then extending it to higher degree inequalities also. जल्दी आ गए आप आज. Yes, 2-3 minutes early so that I could have a talk with all of you. Do I need to watch previous classes or will it be understandable? It depends entirely on you, Gungun. I have already told that topics are interrelated, of course. So it should be manageable. It should be manageable. There should not be much issues. And if there is something, so have patience. Don't pop up in between. There could be something which we had discussed earlier. So if there is anything which is unclear or doubtful, you can certainly go back to that previous part first. Okay, Gungun? And I saw somewhere in between how to cope up with backlogs. So see, your time schedule you have to manage. But in my opinion, that is my only suggestion. Be consistent. Try to be consistent as much as possible. Okay, na? Okay. So that's what I answered, Romil, how to cover backlogs. For backlogs, you just need to manage your time schedule. I'm repeating the same thing. Try to be consistent. So whatever time you are able to find out, so get some time daily. So sometimes you may get more time, sometimes you are not having extra time, but whatever, there should be consistency. Regularity should be there. I understand that your NSM exams must be there for some of you, so it's fine. So, but still, you should try to maintain the consistency. You may not get extra time nowadays because of your college exams, but still the consistency, regularity must be there. At least you must be present in your live classes or practice classes or application classes. If you're not able to do self-study in this duration, it's fine. That just must be a matter of 1 week or 2 weeks maximum, isn't it? No, Bablu, we are just about to start. You are bang on time. Thoda more question में दिक्कत होता. Raghavendra, we are going to start with modulus part tomorrow. Okay. So let's start now. So how to manage self-study along with college. College students are supposed to study only. For working class, it might be difficult because they are not in touch. But for college students, you must study. You must find some time. Okay, so let's start with today's part. I'm just reading one more comment. Pragat says, एक बार में algebra के topic समझ नहीं आता है, 2 या 3 बार देखना पड़ता है. No issues in that. What's the problem with that? It's okay. It's fine. See, honestly speaking, when I remember when we used to teach students in physical classes, when students are sitting in front of me, I'm seeing what he or she is doing, where the student is lacking. At that time also student used to take time. It was difficult to understand the things. But right now when we are distant apart, I can't see what you are writing, and there are right now more than 250 students, and you know it's going to reach about 400, 500 students maybe. You know? So, and still you are getting something. It's really amazing. So don't worry, don't worry. Just try to become better. Fine. Okay, let's start now. So enough of talking today. So as I said, we are going to start with this inequalities part today, and tomorrow we shall talk about modulus. Now please concentrate here. If there are any doubts, any confusions, I will take up your doubts also at the end. Okay, end of the session. So I hope today we will be able to finish in time. I will not take the extra time, and I will try to take your doubts as well if there are any. So in the last part. Okay, let's start now. So prior to this, what we have done, let's quickly recap. So prior to this in algebra, we have talked about linear equations. Do you remember what different things we have talked about linear equations? Please write in comments fast. In linear equations topic, what different things we have studied? Rentim, yes, we had 2 weeks classes before that. Yes, linear equation means degree 1 equation, right? That's true. It's an equation of degree 1. What else? Yes, ax plus by equals to 0, we can say that. Ax plus by equals to 0, that's a linear equation. In 2 variables, there can be 3 variables equations as well. How to solve an equation, and how to solve linear equation. What are the methods? We generally use that substitution or elimination methods. Now we also solved 3 variable equations, 4 variable equations. Basically more variables and less number of equations that we solved, right? And what else? We also solved word problems, right? Word problems. So converting word problems in equations, right? And generally word problems are converted in linear equations only. Sometimes they are converted in quadratic as well, but mostly they are converted in linear equations. So these are different things we studied about linear equations. Also, what will be the shape of graph? What will be shape of graph? Yes, ratio of coefficients will tell us about the simultaneous solutions, right? So the graph will be a straight line. It will be a straight line. And that's why it is called a linear equation. That's why it is called a linear equation. And when there are more than 2 linear equations, so simultaneous solutions, whether the equations are consistent or not, that's what we also discussed based on the ratio of coefficients, and that's it, ratio of coefficients, right? So if ax plus by equals c, or a1x plus b1y equals c1, another was a2x plus b2y equals c2. In that case, based on the ratios of coefficients, we can find out whether the equations are consistent or inconsistent. What was the meaning of consistent? Consistent means the equations are satisfied simultaneously. That means equations are intersecting at one point, or equations are overlapping each other. Concurrent also. And inconsistent means when the equations are parallel to each other. So when it will happen that equations are inconsistent, so that is very easy thing. So when lines are parallel means that ratio of coefficients of x and y is same. a1 by a2 is equal to b1 by b2, but it is not equal to c1 by c2. That means they are having same slope, but their constant part is not common, so they are parallel, no solutions, right? So inconsistent means no solution, or parallel lines in terms of graph. Okay, almost we have revised the complete linear part. Fine. After that, we also talked about quadratic. Right? After this, we talked about quadratic part. So quadratic means degree 2. Yes, quadratic means degree 2. It's ax square. Janvi, ax plus by plus c nahi, ax square ban jayega. Right? So it's a degree 2. Degree 2. And example, ax square plus bx plus c equals 0. Right? Ax square plus bx plus c equals 0. And yes, so for how to solve this, we also learned. So how to solve. So solving methods we discussed 3 different methods, remember? And that one was splitting the middle term. Right? That we have been doing in our school time. And after that, we also discussed one method, completing the square. And another one was using that quadratic formula. And this quadratic formula we are going to use a lot of times. And quadratic formula, I hope all of you remember, it was x equals to minus b plus minus root of b square minus 4ac by 2a. Now this b square minus 4ac, it is called discriminant. Yes, this is discriminant method, we can say. So this b square minus 4ac is discriminant. If I write it as d, so this discriminant, based on discriminant, we can also find the nature of the roots. Right? So, so if discriminant, tell me if discriminant is greater than 0 for a quadratic polynomial, can you tell me the nature of roots? If discriminant is greater than 0, what about the roots? If discriminant is greater than 0, okay, roots are going to be real, right? And distinct or not? Yes, distinct also. Real and distinct. If discriminant is equal to 0, what then? If discriminant is equal to 0, in that case, yes, roots are going to be real and same, equal roots, right? In short, we can write real and equal. Good. Real and equal. Let me write like this. Badhiya. And if this discriminant is less than 0, in that case, roots are imaginary or complex roots, we can say. It's not memorized, it's not ratta. If you understand what is happening, see, we are just seeing this expression. I hope those students who have attended my previous classes as well, for last 2-3 months we are having classes. So I never prefer to memorize the things. If you understand, see, this quadratic expression we already know, right? A, B, C are all real numbers. So this discriminant b square minus 4ac, which is inside the root, if it becomes negative, so a negative number inside a root makes it complex number, imaginary number, isn't it? So imaginary and it becomes a complex number. If it had been 0, then both roots are minus b by 2a only. That means equal roots, right? Real root and equal roots. And if this is greater than 0, in that case we are having two distinct roots. One is minus b plus discriminant upon this 2a, and other one minus b minus root of this discriminant. Fine? So there is nothing about ratta or memorization. You just need to understand. You just need to use the basic things. Okay, so discriminant less than 0, it is complex roots. Complex roots. So in this complex roots, we are going to have this conjugate pair, of course. So p plus iota q, then other is p minus iota q. And same is with irrational roots as well. Okay? So Priyanka, you will get that questions. Don't worry. I have already told you that. So there will be some questions in which you have to think totally new. And there will be some questions which you will be able to use the things which you know directly, right? So both types of questions will always be there. There can never be a point in time that now I know everything. It's not going to be possible. The purpose of examiner is to give you some troubling situations, so don't bother about that. Okay, let's move further. We did some more things also. Let me erase this part. And what else we discussed in this quadratic part? What else we discussed in this quadratic part? One was that some of you were writing sum of the roots and product of roots. Sum of root and product of roots. So I'm writing the expression again, ax square, it is ax square plus bx plus c. So if alpha and beta are the roots, so we can write it as a times x minus alpha, x minus beta, right? And now by equating the coefficients, we got these relations. At sum of the roots, let's call it s, it comes out to be minus b by a. And same with product of roots, let's call it p, it comes out to be c by a. Right? And graphical approach also we saw. So if we are trying to draw a graph for this, so alpha and beta are the points, are the values of x which make the expression equal to 0. That's why they are called roots. Let me repeat, this is very basic and important point. So what is the meaning of roots and what is this alpha and beta? So if I put x equals to alpha or x equals to beta, this expression is going to become 0, right? That means the value of this complete expression, which we call y is going to become 0. So at number line, so at alpha and beta, the graph is going to intersect x-axis at these 2 points. Fine. And if x lies in between them, so we are going to get a negative value depending upon the sign of a. So if a is positive, in that case, the graph comes out to be upward parabola like this. It's also called bell-shaped structure. So it is going to be upward parabola if a is positive. Acha, can you tell me in this diagram, if I put, let's say, let me write it like this, f of, this is fx is equal to ax square plus bx plus c, okay? And alpha and beta are the roots, alpha, beta are the roots. And a is greater than 0. Okay? These are all information is given. These are all information is given, and diagram is already drawn for you. My question is, f of alpha plus beta will be, what will be the value of alpha plus beta? Will it be, options are, will it be positive, negative, or 0? These are the options. Please answer. Okay, Shaurya says positive. Somebody says 0 as well. See, ratta memorization will not work. You need to think. Okay, I'm getting mixed answers. Some of you are saying positive, some of you are saying 0. Agrima also says 0. Alpha plus beta is minus b by a, that's fine. I'm asking f of alpha plus beta. That means if I put the value of x as alpha plus beta. Achha, tell me one thing. Alpha ki value jo bhi, alpha, beta, is clear that alpha is smaller than beta. So alpha plus beta will be certainly larger than this. Right? Alpha plus beta will be certainly larger than this. So let's say alpha plus beta lies somewhere here. This is the value, let's say alpha plus beta. Let's assume this is alpha plus beta. So at x equals alpha plus beta, what is the value of y? Is it positive or negative? Of course it is positive. So it can be determined, what is this, Jayanti, if I'm Jayanti, whatever it is. So it is going to be positive, right? So f of alpha plus beta is certainly positive. I do not know what is alpha, I do not know what is beta, I do not know what is fx, but just based on this information, we can certainly say that f of alpha plus beta is going to be positive. Fine? I hope you are understanding the concept. So basically, the algebra is totally based on concepts. So if you are able to understand, you can do the unsolvable things also. But if you are just going to mug up some of the formulae, then it's going to be certainly difficult. Akriti sir, please guide a little on this question. बाद में, not now. Akriti, please we'll take it later. Your doubts, whatever you are having, I will try to finish this today's topic fast, and then we can take up some questions later. Whatever Vignesh is asking, if alpha is negative, whatever it be, we know that alpha is smaller than beta, right? On this graph, we can see alpha is smaller than beta. Right? I'm using this graph as the information for this question only. So alpha plus beta is going to be more than beta for sure. So that's how we are able to answer it. Fine. Okay. Let's move further. Now, can you tell me at what point are we going to get maximum or minimum value of this quadratic polynomial? हाँ, Jayanti ji, that's a good thing. So I accept your views anyway. So that was my whole idea here. So alpha and beta and alpha plus beta, I'm assuming it is more than that. So that's right. If both of them are negative, in that case, alpha plus beta will become less than this also. So by the way, if alpha and beta both are negative, suppose if alpha and beta both are negative, in that case, alpha plus beta will be less than alpha, right? That's what you are saying. In that case also, by the way, this is going to be positive. Anyway, I hope you have understood the idea what we are discussing. Right? You have understood the idea what we are discussing. So point is that, so just on the basis of information, we can see what is the shape of the graph, and accordingly we can answer. Okay, now I'm asking, what about the maximum or minimum value? So at what case we are going to get maximum or minimum? Yes, it is minus b by 2a. So at x equals to minus b by 2a, which is basically the midpoint of the two roots, right? This midpoint of the two roots. So we are going to get the maximum or minimum value depending upon whether the graph was upward or downward parabola. So in this particular graph, it is an upward parabola. So this value of y, or that expression, this is the minimum value here, right? So when a is positive, we are going to get a minimum value, or if a is less than 0, in that case we are going to get maximum value. And in both the cases, whatever is the value, that we can find out by putting x equals minus b by 2 in the expression. On simplification, we get a simple expression also. So this maximum or minimum value, it comes out to be minus d by 4a. Those people who are fond of formulae, they can revise this, remember this also if you wish. So this maximum or minimum value comes out to be minus d by 4a. And how did we get this value? Just by completing the square only. That's 2. It's minus d by 4a. It is just by completing the square only. So if you wish to remember the formula, you can. Otherwise, we know that we just need to see the value. We just need to put the value of x, which is midway between the two roots. That's minus b by 2a. So by seeing the expression, we can find out the value of x at which this is going to be minimum or maximum, and we can substitute that value to get our answer. Fine. All right. So as Rashna is saying, if one root is minus 3 and other 4. So if one root is minus 3 and other is 4, can you tell me the value of x? Can you tell me the value of x at which we are going to get maximum or minimum value? GIS, you can attend the previous classes first. If there's some difficulty, you can attend the previous classes first. No issues. Yes. So minus 3 and 4 are the two roots of an equation. In that case, their mid value. What is going to be the mid value? It is 0.5. It is simply alpha plus beta by 2. Alpha plus beta by 2. 4 minus 3, 1 by 2. So at 1 by 2, at x equals to 1 by 2, this parabola having minus 3 and 4 as the two roots is going to get its extreme value. Fine. Okay. Can you tell me whether we are going to get the maximum value or minimum value here? It is not sure now. It is not sure. Because this parabola, which is having two roots as minus 3 and 4, it may be an upward parabola passing through these 2 points, or it may be a downward parabola as well. It may be a downward parabola as well, passing through same two roots. Fine. So whatever be the case, at x equals to 1 by 2, it is going to have its extreme value. So whether it will be a maximum or minimum, it depends upon a. That means just this information doesn't satisfy. Fine. Okay. Anyway, so all these parts we had discussed. I think let's move further. And we also discussed other than this about the polynomials, right? Polynomials of higher degree 3, 4, and so on. Okay. So this is the whole part which we had discussed in the previous classes. So let's move further now, and we will be continuing with the same idea to find maximum minimum value of the expression, quadratic expression. Right. Okay. So let's move further now. So we are going to talk about now maximum or minimum value of any quadratic expressions, as we had just discussed. So for any quadratic expression, ax square plus bx plus c. So it is going to have this. This is a quadratic expression. Let's call it y. So y maximum we are going to get when a is less than 0, and y minimum we are going to get when a is greater than 0. When a is greater than 0, the parabola was upward, and when a was less than 0, the graph was downward parabola. So in this case, or this case, both cases, the maximum minimum value numerically, it looks like the same expression. It is minus d by 4a. So that was our conclusion. Fine. So this is the whole part. That's it. Right. And this is in terms of formula, or otherwise we had done various ways. We could have completed the square, and then also we can find the value, or by putting x equals to minus b by 2a, we can substitute and get our answer. That's it. Right. Okay. Let's quickly do 2-3 questions, and we shall proceed further. I hope this part is clear. There should not be any doubt. Priyanka is asking minus b by 2a and minus d by 4a make a difference. Arey Priyanka, x at x equals minus b by 2a, we are going to get the maximum value or minimum value. And what is that value? That is the value of y, which is minus d by 4a. That is the case. So this is the maximum or minimum value depending upon a, and at what value of x we are getting it? At x equals minus b by 2a. So don't be confused in that. That's what I said. If you are trying to remember the formula, you are going to be confused certainly, and it is very difficult. So but if you understand the thing, then it's fine. Then also then you can remember formula. Okay, let's move further now. So here's the first question for you. Please answer it fast. You have to find the minimum value of the expression 2x squared plus 5x plus 1, and also find the value of x where the expression attains this minimum value. It's a direct question now. Answer fast. It's a part of your inequality class only, those who are asking about it. I'm seeing different answers on comment. Please recheck your answers. There should not be different answer to a question. Okay, at x equals minus 5 by 4, that's correct. And what is that value coming out to be? We can substitute the value and get the answer. Okay, as we had just discussed, equating this expression 2x squared plus 5x plus 1, let's equate it with ax squared plus bx plus c. We can easily see that a equals 2, b equals 5, c equals 1. Fine. Now a is positive, it is going to be upward parabola, and we are going to get minimum value. So at what value of x? So at x equals minus b by 2a. Just substituting these values. So minus 5 upon 2a, that is 2 times 2, 4. So at x equals minus 5 by 4, we are going to get the minimum value. And what is that value? So that value of this expression, this y minimum, is basically minus d by 4a. What was d? It was discriminant. That is this b square minus 4ac upon 4a with negative sign. So now we can substitute the values. So b square, that is 25, with negative sign, this is 25, minus 4ac, 4 into 2, it is 8, upon 4a, 4a means 4 into 2, 8. So yes, that's correct, it is minus 17 by 8. So most of you have got the answer correctly, that's nice. Anyway, this was the direct question. Let's move further now. Next one. Again, similar question, find the maximum value of the expression. Yes, Aditya, that was correct. In the previous case, it was upward parabola. Now in the second question, at what value of x? We are getting again different answers here. At x equals minus 2, Anurag says. Okay. Is that right? I don't think so. See, equate the expression correctly. A is not 1, A is minus 3 here, isn't it? Okay, let me write it again. So this is minus 3x square plus 2x plus 1. So I've written the expression in our general standard format. So at x equals 2, yes, 1 by 3, Aditya, that's correct. At x equals 1 by 3, we are going to get the maximum value. How? First I'm equating it with our standard format, ax square plus bx plus c. That means a equals negative of 3, b equals 2, and c equals 1. As a is negative, it means the graph is a downward parabola. That means we are going to get a maximum value, which is already given, by the way, right? So at what value of x we are going to get this maximum value? At x equals minus b by 2a. Now just substitute the values. So b is 2, so it becomes minus 2 upon 2 into a. So that is minus 3 into 2, that makes it minus 6. So it comes out to be 1 by 3. So at x equals 1 by 3, we are going to get this value. And one way is we can substitute this value only, or otherwise we know that value is going to be, this is why maximum is going to be same, minus d by 4a. Fine, d is same discriminant, d square minus 4ac. So with negative sign, this b square minus 4ac upon 4a. Now again substitute the values. So b square means 4. With negative sign, I'm having this 4. And this 4ac, 4 3 are 12, is minus sign, so minus 12. And this, we have to subtract this, it becomes positive. So positive 12 upon 2, this 4a. So a is again minus 3, so minus 3 into 4 makes it minus 12. So minus 12. So this minus and minus got cancelled, so we are going to get a positive value. So 4 plus 12 is 16, so it is 16 by 12. You can cancel out the 4. So 4 4s are 16 and 4 3s are 12. So answer is 4 by 3. Fine? Yes, so 4 by 3 is the maximum value at x equals 1 by 3. Again, similar question. It was not difficult. Okay, let's move further now. I hope all things are clear so far. Raghavendra says differentiation se jaldi ho raha. Yes, those who are comfortable. See, we had done different methods. So whatever method you are comfortable with, you can go with that, no problem. But we should be conversant with other methods as well, right? It's not that one method is going to be suitable always. It's not going to be the case. There will be different varieties of questions. Yes, it is downward parabola. And how did I got to know? Because A is negative. Okay, let's move further to the next question. Okay, now solve this one. Let P and Q be the roots of, this is a cat question basically. P and Q be the roots of the quadratic equation x square minus a minus 2 into x minus a minus 1 equals 0. What is the minimum possible value of P square plus Q square? That's a good question. Try to solve it now. Shruti is asking some silly question. What is that silly question? Can we directly jump to get y equals? Why do you want to directly jump, Shruti? Don't. Take small steps so that there is less chance of slipping. Some of you are getting directly answers. Have you solved this question earlier? Yeah. Vyas says 3A and others. I can see Anurag, Kavya, Pranav, Anshita, Ankik. They are directly saying 5. Are Manu Prakash, third indices completed? Yes, we did some few questions in the last class. We did few questions in the last class. More questions you can practice from your different other sources. How you people are getting the answer so fast? Most of you are saying 5. In between I am seeing other 6 as well. अच्छा पहले कर चुके हैं क्या? Okay. I don't remember. हो सकता है maybe. Okay. You remember the answers? I don't remember. I've done this question so many times, but I don't remember the answer. Anyway, okay, now tell me how to do this. This P and Q are the roots of this equation, quadratic equation. We have to find the minimum value of this. So how to start? What is the first step? I also done this. This is a previous cat question. Yes, I told that, but I don't remember the answer. You people remember the answer. Yes, how to solve it? What is the first step? Let's do it together now. What is the first step? How to start? Identity. Which one? Sum and product of roots. Okay. So sum and product of roots, that is P plus Q. You can say P plus Q is A minus 2, isn't it? P plus Q is A minus 2, sum of the roots is minus B upon A, so minus A minus 2 makes it A minus 2, and the coefficient of x square is 1 only, so P plus Q is A minus 2, and PQ is product of roots, which is C by A, so C here is negative A, negative 1, and the coefficient of x square is 1 only, so P into Q comes out to be minus A minus 1, ठीक है, and after that you are going to apply identity, okay, understood, so after that you are going to apply the identity, and identity is this, we want P square plus Q square, so P square plus Q square you will get from this, P plus Q whole square minus twice of PQ, isn't it? Yes, if you were to solve this now, certainly it's going to take some time. But all of you were remembering the answer, that's why directly you wrote that down. Anyway, so now I just put the values here. So P plus Q whole square, that means A minus 2 whole square. And negative 2 times this value, so negative will become positive, so it becomes plus twice of A plus 1. Fine. Now we just need to simplify this expression, and it is going to be quadratic in terms of A, and then we have to find its minimum value. Right, that's a question. Okay, let me simplify this. So here I'm going to get A square, and there is no A square term, so it is A square only. From here I'm going to get minus 4A plus 2A. That makes it minus 2A. And here I'm going to get plus 4 and plus 2 makes it plus 6. Is it not? Right, so it is A square minus 2A plus 6. And this time I don't want to use that earlier method. This time I would prefer to using the completing the square part. Which year cat question it is? ये पुराना सवाल है. I think it's about early 2000s, maybe 2002, 3 something. I don't remember exact year. इतनी धीरे सोल्व नहीं करते. Okay, let's see. So now the next step is I'm using the completing the square part now. So it is A minus 1 whole square, because A square minus 2A plus 1. So the extra remaining part is 5. So 5 is my answer. So at A equals 1, 5 is the minimum value. Yes, completing the square. Fine. Yes, good. Okay. Good. So you had done this question earlier. That's why you are able to answer it fast. So that's a good memory. You are all young chaps. Okay, let's move further to the next question now. Have you done this one also earlier? For x is a real, find the maximum and minimum value of x square minus x plus 1 upon x square plus x plus 1. Wait, Satyajit is asking, sir, 5Q please again. Arey bhai, we had done that earlier. See, now this is the quadratic expression whose minimum value we have to find out. There are various ways. You can do it by the earlier method. At x is equal to minus b by 2a, the minimum value will be minus d by 4a. That's it. Or I have used this time the other method of completing the square. So if I complete the square, so this can be written as a minus 1 whole square plus 5. See, a square minus 2 plus 1 is a perfect square, na? So this plus 5 is remaining. So now this a minus 1 whole square, its minimum value is going to be 0. So the minimum value of the complete expression is 5 only, when this term becomes 0, right? Anyway, so let's move to this question. How to solve this? Yes, you have not done this question earlier. Akanksha, the minus 2a plus 2a कट जाएगा, but पिछली बार minus 4a था ना वहाँ पे. Akanksha, in the last question it was minus 4a and plus 2a. Okay, this one now. How to start this? Any hint, any idea? लव इज आस्किंग इन्फिनिटी को रियल मानते क्या? नहीं मानते. नो. Equate to n and then create a new equation. Yes, that's good idea, Vyas. That's correct. Sayani is asking something to y quanta. Okay. Component or dividendo se hoga. No, Nita, it will be difficult. Component or dividendo, to use that, we need to have something in it's equal to this also. So here component or dividendo is not a possibility. I don't think so. Okay, so I got one nice suggestion by here by Vyas. So let me write that. He suggested let's equate it to some value and then make a new equation, make a new quadratic equation. Okay, so let me write. So he's suggesting that x square minus x plus 1 upon x square plus x plus 1. We want to find the minimum and maximum both values of this polynomial expression. It's not polynomial anymore. It is a ratio in a way, it's a fraction in a way. The numerator part is a polynomial, quadratic polynomial. Denominator is also quadratic polynomial. So let it equal to be n. So here we need to find the minimum and maximum value of n. Okay? And as somebody was asking, we can't take the denominator to be 0. X is a real number. This is given. X is a real number. So, but we are not going to make the denominator equal to 0. So now how to simplify this? So first just rearrange, cross multiply and rearrange to make another equation in terms of x. So what we are going to get? Yes, answer is 3 1 by 3. That's correct. Many of you have got. I think by using your differentiation, some of you can find that. Yes, Vyas is suggesting nice thing. So see, now what we are doing, so by equating it with n, I'm creating another quadratic equation. कैसे बनेगा? Let's see. So it's x square minus x plus 1. And if I take this denominator on the right hand side by multiplying with n, it becomes n times x square plus n times x plus n, isn't it? Now bring all these terms on the left hand side. So we are going to get 1 minus n times x square. And what else? This will be negative 1 plus n times x and plus 1 minus n equals 0. Is this equation fine? Now that's a new quadratic equation. Aditya is asking, इसका shortcut नहीं है. Don't go for shortcuts. First understand the things, and then we shall see alternate ways also. First do this. So this is okay so far. This is a new quadratic equation in terms of x again. Now because x is a real number, because differentiation से कैसे होगा? I did differentiation last time when I was in my first or second year of engineering. After that I have not done that. So it has been more than 25 years now. So I don't know how differentiation कैसे होगा, and it will take time. So leave that for now. And those who are doing who are still using differentiation, so they can suggest you that. But right now, let's focus here. What we are going to do. So this we have equated with n, and we made another quadratic equation. Now, what step need to be applied? Vyas only suggested. I'm using that part. So the discriminant should be a positive number or equal to 0 also, because x is a real number, right? X is a real number. So roots are going to be real, and roots real कब होंगे? When the roots will be real, when discriminant is greater than equal to 0, which means b square minus 4ac, that is 1 plus n whole square minus 4 times 1 minus n into 1 minus n, that means 6 square. It should be greater than equal to 0. Fine. So that is the condition here. Yes, Aditya, you are right. Yes, you are right, Aditya. You can do that. Right, Raghavendra, that's true. So those who wish to go for differentiation, you can do that later. But right now, see here what we are doing. So this is a quadratic equation, and now in this quadratic equation, we know that x is a real number. So when x can be real, if discriminant is greater than or equal to 0, and now this discriminant comes in terms of an n. Which repeating last step, Pranjal? I'm repeating all the steps. Which step are you talking about? Please be specific. Okay, let's move further now. We are going step by step only. I'm not skipping any step. These are all the steps here. So, what is the benefit of this now? Now, this discriminant is a quadratic expression in terms of n only. So, this is going to give us all the values. Now, let's simplify this. Pratishtha, after that, there is no requirement of differentiation. Yes, you can do that, by the way. Okay, let's simplify this. If I simplify this, what I'm going to do, a square minus b square, let me use the identity here. It is a square minus b square. So, it becomes 1 plus n plus, this is 2 minus 2n, right? So plus 2 minus 2n. A plus b, a minus b. So 1 plus n, so minus 2 plus 2n. That is greater than or equal to 0. Fine, I just use a square minus b square identity. I hope all of you know that a square minus b square is equal to your a plus b into a minus b. Yes or no? Right, so we have just used this identity to write this final expression. Now simplifying this, we get 1 plus 2, it is 3. So this is 3 minus n. And this one is how much? 2n plus n, that is 3n minus 1, which is greater than or equal to 0. Till this point, if there is any difficulty, please ask me. 4 का क्या हुआ? Arno, 4 is 2 square, na? 4 is 2 square, so it becomes 2 minus 2n whole square. So a square minus b square, so this 2 minus 2n. So this 1 plus n plus 2 minus 2n, 1 plus n minus 2 plus 2n. That's what has happened with 4. Is it okay? Exactly. Thank you, Kavya. Is it okay so far? Now we are almost done. So what this expression has become, let me rewrite it here. So if I take negative common here to make it n minus 3, so this sign is going to be changed here. So n minus 3 and I'm also taking 3 this outside, so this will become 3 times n minus 3 into n minus 1 by 3, and as I've taken minus outside, so this sign is going to change. It will become less than or equal to 0. Now that is the expression. Sure, this 4 into 1 minus n square is equal to 2 minus 2n whole square. 4 you can take inside the bracket now. 4 is 2 square. 4 is 2 square. So 2 you can take inside the bracket. And what is the benefit? Now it becomes a square minus b square, so that we can directly use the identity. Fine. हाँ, that's a good point. Good. Gaurav is asking, sign कैसे change होता है? How do we get to know sign change होगा? Sign change is a good point. So we should discuss that. Riya 4 वाला step ये रहा. Here's the 4 वाला step. Those who are confused about 4 वाला step, this is 4. This was 4 times 1 minus n whole square. 4 means 2 square, so I can take it inside the brackets, so it becomes 2 minus 2n whole square. So that's how we have used identity a plus b, a minus b. ठीक है? Narayan Singh is, which step you are talking about? Acha, here you, it's okay, it's fine. That's true, Narayan. You're talking about the sign part, na? That's fine. The same thing is here. Anyway, see, sign change कैसे होता है वाली जो बात थी, let's talk about that. One thing is that, as Narayan is suggesting, so in spite of taking all these RHS values on LHS, if I would have taken LHS to RHS, तो sign change आता ही नहीं. That's what Narayan is saying. That's fine. Anyway, right now we have written it like this. So if I'm taking this, I'm writing it as n minus 3, it is becoming minus times n minus 3. ठीक है ना? So minus times n minus 3, when we take whole side on the other part, it becomes less than equal to 0. That's what is happening basically. See, if I say this 5 is greater than equal to 0, greater than 0. Let's take an example. Let's take this example. 5 is greater than 0. That's true, right? 5 is greater than 0. That's true. Now, if I multiply a negative sign here, so negative of negative 5 is also greater than 0. ठीक है ना? Yeah. Let me write it like this. If I subtract 5 both sides, that would be easier to understand. If I subtract 5 both sides, minus 5, minus 5. Fine. If I subtract 5 both sides, what will happen? The sum would be 0 is greater than minus 5. Or we can say minus 5 is less than 0. So that's what is happening. So if I take 5 on the other side, sign changes, right? So it becomes minus 5, and inequality 5 was greater than 0 and minus 5 becomes less than 0. So that's what is happening basically. Right? That's what is happening basically. So same way here, it was 3 minus n. So if I'm taking negative common, it's minus n minus 3. So when we take this expression on the other side, so that minus is removed and it becomes less than equal to 0, as we are written here. Fine. So that's how the sign change thing happens. But as Narayan suggested in between, so if we would have taken LHS on the RHS, so this step aata hi nahi. In that case, this step would not have been required at all. Anyway, let's come forward now, move further. So this n minus 3 into n minus 1 by 3, if we see this expression, what you can say about this expression? Is it a quadratic expression or not? Is it a quadratic expression or not? I'm waiting for your answer. Yes, it is a quadratic expression, right? It is a quadratic expression. See, less than equal to 0, leave that part for the time being. This n minus 3 into n minus 1 by 3 is a quadratic expression with the leading coefficient being positive, right? Leading coefficient being positive. So the graph is going to be upward parabola or downward parabola. Please write. Graph is going to be upward parabola or downward parabola. Hi, yes, Shubhangi, that is also true. We are going to discuss that part also, but we are discussing a better method now. Shubhangi is saying we can discuss them separately. Their product is negative, so one of them will be positive, one of them will be negative. We can make cases. That's one of the ways. Fine. But right now, see the better method now. This is a quadratic expression. It is going to be upward parabola, right? So let me draw. This is going to be upward parabola, right? And it is intersecting this x-axis. If I consider this n as x only, right? So it is intersecting this axis at 2 points, which is 1 by 3. 1 by 3 is smaller, and then this 3. 3 is the larger one. Fine. Is it okay? Basically, now this graph which we have made, this normally which we call x-axis, basically it is n-axis. These are values of n. So n is varying from minus 1 by this 1 by 3 to 3, right? And because this expression is going to be less than or equal to 0, that means only admissible values, only possible values for this entire expression is only below this graph, below this axis. That means these only, right? So these are the only possible values here this complete expression can take. So in this case, can you find out what is the maximum value that n can take? Of course, it is 3. What is the minimum value n can take? It is 1 by 3. 1 by 3 kaise aaya? This is 3 and minus 1, beta. Who is asking this? Kshitish. So 3 and minus 1 say I have taken this 3 common. That's how it looks like, n minus 1 by 3. Yes, I'm repeating last step again. So this 3 times n minus 3 into n minus 1 by 3, this is less than equal to 0. From here we saw this is a quadratic expression intersecting the axis at 2 points, 3, 1 by 3. It's an upward parabola because leading coefficient is a positive. Okay? And because this is less than equal to 0, that means the value of this graph we are to take only in this range when it is less than 0. Okay? So now we need to find the maximum and minimum possible values for n. So n was on this axis. So on this axis, the graph is possible only here. So n maximum can go up to 3 and minimum can go up to 1 by 3. Suppose in this question, okay, let me ask you, if in this place, if it would have been greater than or equal to 0, suppose if it would have been greater than or equal to 0, in that case, what could you say? If it would have been greater than or equal to 0, in that case, which graph we should have taken? In that case, we should have taken the graph, this beyond 3 and before 1 by 3. Is it not? Ulti kahani ban jati. So in that case, the maximum value of n is infinite. The value of x will become, n will become infinite, and the minimum value will also, minimum value will be what? That will also be minus infinite. Yes, minus infinity to infinity. Right. Fine. So basically the point was that only. So seeing the quadratic inequality, how we can find the maximum or minimum value of the expression. Okay? Okay. Now let's look for an alternate way also. Yes, you can watch it again, no problem. And these steps are all important steps. That's why I've made you focus on this. You can use differentiation or you can use some other thing also. But converting it in a quadratic equation, and then because x is a real number, so discriminant must be greater than or equal to 0. Using that fact to create an inequality in terms of this n, whose value we want to find out. This is an important method. Yes. Now some other method now, some alternate method now. So you can rewind it. You can revise it later again. You can revise it, watch it again later. So for the time being, we are going to discuss another method also for this question. I think another method we should discuss after discussing the basic concept for that. So just wait for this. And mark this question in your mind. Okay? I will come to this question again, and it's a 2-step question. It's a very fast question. Harsh Gupta is saying itna karna pade to skip karna is better. No, if you are going to get all questions like that, only in that case it's not good to skip all the questions. We should know how to do it. Anurag, we have to discuss the basic concept for that. After this, the next topic is that only. So just keep this in mind. I'm also having the same thing in mind. So we will discuss it. Let's move further now. This is the next topic. In this part only, we are going to cover that part, and then we will solve this question. Okay, so introduction to inequalities. So inequalities, as we had been solving now also. So if this x plus 5 is greater than 0, what are the possible values of x? Can you tell me? Love Krishna, have some patience. I will come back to that. Please have patience. I will come back to that. Don't worry. X plus 5 is greater than 0. Can you tell me the possible values of x? X should be more than minus 5, right? I didn't say, Riti, that x is going to be integer. X can be anything. X is any real number. So x plus 5 is greater than 0. So as we just saw in the previous slide. So if I take 5 on that side, it means in other ways we can also say subtracting 5 both sides. So that gives us x should be greater than minus 5. So number line, if we see, this is 0 somewhere, this is minus 5, and this is plus 5, like that. So x is greater than minus 5. So greater than minus 5 means on the right side of minus 5, excluding this value minus 5. So excluding this value on this side. That means we can write the answer as this only, x greater than minus 5, or in terms of range, if we will write minus 5 to infinity. So x belongs to this set, minus 5 to infinity, and because minus 5 is not included, so we use this bracket. And with infinity, always we use this bracket. So whenever we use this round bracket, it means this extreme value is not included. Yes, minus 5 to infinity, that is the right answer. Fine, that was just very basic question. But in the CAT, sometimes we get, of course, heavy expressions with the same question. We have to find the possible values of x which satisfy the given relation. So minus 5 is not included, that's why. Okay, let's move further. If it is given that minus x plus 5 is greater than 0. Now what about x? Now what can you say about x? Exactly the same way as we did last time. I can think in that way. Either you are taking minus x to on the other side, it becomes positive, and x comes out to be less than 5. Or in other sense, it can be seen as that also. Adding x both sides, that makes it x cancel on the left hand side, and right hand side x will be less than 5. So that's the answer. So it is minus infinity to 5. Again, excluding the boundary values. Now, if this product is given positive, say x plus 5 multiplied with minus x plus 5, this product is positive. Now how to solve it? Please solve this one. X plus 5 into minus x plus 5. Now this is positive. This is more than 0. Yes, we can call it compound inequality, or you can say quadratic inequality also. minus 5 to 5, most of you are saying, but in between I'm getting some different answers as well. How to solve? How to solve? Should we deal with them separately? As someone was suggesting earlier, that let x plus 5 is positive and minus x plus 5 is also positive. Both are positive or both are negative. There are two things possible, right? Because this is product of two terms here, and the product is coming out to be positive. That means either both are positive or both are negative. That is one way to solve, right? And that can take time. That can take a lot of time. Yes, Tanish is also suggesting the same thing. Deal with them separately. So if we deal with them separately, in that case we can use number line. That's true. So this term is positive as well as this second term is positive. That is one case. Another case could be that both the terms are negative, because in both the cases the product is going to be positive one, right? Or the other method is we can use it as quadratic inequality. That will be certainly better. But let's first see it now here. So x plus 5 is positive. We have already seen that. So x lies in this range, minus 5, greater than minus 5, right? And when this part is positive, minus x plus 5 is positive. In that case, we have seen minus infinity to 5. So minus infinity to 5. From minus infinity to 5. So like this. So this is the first part we have already done. When both terms are positive, this is positive. So this was the first step. And with minus x plus 5 is positive, we have done it here. So x comes out to be in this range, minus infinity to 5, or starting from 5 and going up to minus infinity. So now we have to see the common region for both of them, and the common region is this part, excluding minus 5 and 5, and in between them. So as someone was suggesting, minus 5 to 5. Right, so minus 5 to 5. We have to take only common part, because in this case we are not looking whether this should be true or this should be positive. We want this should be positive as well as this second term must also be positive. So both terms must be satisfied. Both terms must be positive. This and this, right? So we need to look for the common part, and the common part is x should lie in the range minus 5 to 5. ठीक है ना? Is it fine so far? So we need to take the common part of both the cases. So it should be minus 5 to 5. Not union. Some of you are saying union, not union. Minus 5 to 5. Yes, that's correct. Okay, Sriram Kumar is saying very nice thing. We'll come to that. Okay, so minus 5 to 5 is one answer. So minus 5 to 5, of course, excluding the boundary value. So this becomes our answer for this case when both are positive. If both are negative, in that case, what is going to happen? There's not going to be anything common, because if x plus 5 is less than 0, both terms are negative, then x will be less than minus 5. Then x will be less than minus 5. So first case will give us the values. The x is less than minus 5 up to minus infinity. And the second case will be x is more than 5 up to infinity. So in this yellow region, in that yellow region, there is nothing common. So here we would not be having any common solution. ठीक है ना? So this won't satisfy. So this is our answer, and what we have done, we have dealt with them separately as a linear inequality. Is it fine? Okay, now many of suggestions I can see here. He directly taking it as a quadratic inequality. Use wavy curve. I can see Arnab is saying yes. Okay. Now let's see it. Shubhajit is asking, oh, ये कौन सी method है भाई? Okay, see it here. So we are going to discuss this part now. This is a quadratic inequality. First, let me erase whole ink on the board. And our question was, I'm writing it again. Question was x plus 5 into minus x plus 5. This is greater than 0. So we have to find the values of x. Okay. So as I did last time, I'm just taking again negative part common. So it comes out to be x plus 5 into x minus 5. Okay. I've taken this minus common. So if I'm removing that minus, tell me, will it be greater than 0, less than 0? It should be less than 0 now, right? Sign will change. That we already discussed. This will become less than 0. Fine. Now this is a quadratic expression. Just see this part. Just see this part. So what are the critical points on the number line? What are the critical points on the number line? It's minus 5 and plus 5, right? So at minus 5, this term will become 0. At positive 5, this term will become 0. So this is an upward parabola passing through 2 points, minus 5 and 5. No need to draw it actually, but we can draw also. Yes, some people call it sign change method, some people call it wavy curve method. Basically, it is quadratic. It's a polynomial curve, basically. It's a polynomial curve. So right now we are having only 2 terms, but there can be cases when we are having more than 2 terms also. Okay? So minus 5 and 5 are the 2 critical points through which this graph is going to pass. And this is going to be upward parabola, like this. Which means the value of the expression is going to be positive when the value of x is more than 5. In this region, the value is positive for this expression, isn't it? The value will be negative here, and the value is positive here. So that's what, as somebody was saying, sign change or wavy curve. So this is wavy curve. So between these critical points, the value is negative. Greater than 5 pe, the value is positive, and less than 5 pe also it is positive. So this sign changes alternately always. Who will answer this? Bhanu Prakash is asking, why upward parabola? Can somebody answer? How do I get to know it's upward parabola? How do we know that it's an upward parabola? Yes, a is greater than 0. The coefficient, leading coefficient of x square is greater than 0. Leading coefficient is positive. Fine. Okay, in between I am having one more doubt here. Who is it? Ria is asking, sir, the bracket represents that both extreme values are not included. No, bracket doesn't mean that, Ria. Here this inequality sign, it is written less than 0. Equality is not here. If it would have been equality here, in that case we could have considered the boundary values as well. Right? Now it is only less than 0. That's why we are considering this negative part. Because at these boundary values, at x equals to 5, this is going to become equal to 0. At x equals minus 5, again this is going to become equal to 0. That's why we are leaving that. Okay, this is one thing. Now listen, tell me one more thing. Suppose if I forget this, most of you are saying that leading coefficient is positive, that's fine, that's true. But suppose I don't remember that, I forget that, then what to do? And see, those who can think, oh, I will not forget, you may think like that. But if there are going to be 3 terms, 4 terms, 5 terms, many terms, then what do you know about that? It's not going to be the case always. So how to do it? Please think carefully. Now listen carefully. We have got to know that 5 and minus 5 are 2 critical points here, right? Now just check. Please just check. Please listen carefully. Just check now. If I take the value of x more than 5 in this expression, I repeat, just put the value of x more than 5. So if I put more than 5, remember, I'm putting the value of x more than 5 on the right hand side of this 5. Okay? So what will be x plus 5? Positive or negative? Positive or negative? If I'm taking x to be more than 5, it's going to be positive. Isn't it? It is going to be positive. And because I've taken x to be more than 5, so x minus 5, this will also be positive. Yes or no? Right? And product of two positive terms, what will be the value? Positive or negative? It will be positive. So it confirms, whether coefficient is positive or negative, leave that for the time being. So this complete product is going to be positive into positive, that is positive. That means when x is more than 5, the value of the graph, value of the expression is going to be positive for sure, right? And the moment you come at this critical point, it is going to become equal to 0. And the moment you come below 5, but more than minus 5, again you can check the values, you will get that value negative. Right? When it is less than 5, but more than minus 5. More than minus 5 will make it positive, will keep it positive, but because it is less than 5, so this term will become negative. So the product is going to be negative. That's how this sign changes alternately, always. Positive, then negative, then positive, then negative, and so on. Is it fine? So that was the whole idea. So that's some different names we saw in the comments, wavy curve method, sign change method, or whatever. Is it fine? So this is positive, this is negative, this is positive. This is a range in which the expression is going to be positive or negative or positive, like that. So in this particular question, we were looking for the negative values, and it is very clear. So when x lies between minus 5 and 5, answer we are going to get the negative answer. Is it fine? So the answer is clearly minus 5 to 5, excluding the boundary values. That's why we are using this round brackets. So x belongs to this set. So this is our final answer. So I'm sure this dealing with them individually, it's better to use this part. Fine? Okay, let's move further now. I hope there should not be any doubt. And we are going to solve a lot more questions based on this. This was just an introduction to this topic. Okay, okay, let's move further. There are many more questions here. Please answer this one. For what value of x minus 1 into 3x plus 2 is greater than or equal to 0? Please answer fast. We are going to discuss with more terms as well. Don't worry. First answer this one. First answer the question. Good. Nimisha is telling the critical points here. It says 1 and minus 2 by 3. That's perfect. But we need to find for what values of x this is greater than or equal to 0. So we need to find the entire range of x. Shweta says minus 2 by 3 to 1. Is it so? No, I guess. Karan, that's perfect, Karan, good. Minus infinity to minus 2 by 3 and then 1 to infinity. That's 2. Okay, see everyone. First way is that only we can deal with them separately. Their product is positive. So one of them, both of them are positive or both of them are negative. So we can deal with them individually as a linear inequalities, and then we can find the common values of x which satisfy them, and accordingly we can get our answer. Certainly that is going to take a long time. I'm not going to discuss that. So let's directly come to that quadratic inequality part, or that wavy curve method which we were just naming it. So the critical points here are 1 and minus 2 by 3. Is that point clear to everyone? Minus 2 by 3 and 1. These are the two critical points. Is that thing clear to everyone? I hope there should not be any doubt in this, right? Critical points are those values of x which make that particular term 0, right? X equal to 1 will make this term 0, x equals to minus 2 by 3 will make this other term 0, right? These are the critical points. So these are the two critical points, and now we were to see, we know that it is going to be alternate positive, negative, but where it is going to be positive? So by the way, it is only quadratic polynomial. We know it is upward parabola because of the leading coefficient positive. So of course this part is positive, this range will be negative, and this will be positive. Or if we are doubtful, so we can put the values as we did earlier. So if I take value of x to be more than 1, so more than 1 this is going to be positive, and more than 1 this is also going to be positive. So that makes it positive into positive, positive only. Fine. Okay, now see our requirement. Our requirement is we want the expression to be greater than or equal to 0. So should we consider the in-between range? Of course not, because this in-between range will give us a negative value for the expression, while we want it to be greater than or equal to 0, because equality is included, so we will include these boundary points. So on the right hand side we can take the values from 1 up to infinity, because 1 is to be included, we will use this square brackets. Fine. And same way from left hand side again, minus 2 by 3 up to negative of infinity. So minus infinity to minus 2 by 3, and this minus 2 by 3 is to be included, so that's why we will be using here this square brackets. So their union, that will be the value of x. So x belongs to this range. Is it fine? No problem, Prerna, it's fine. Bracket खोजने में time लग गया, it's okay, no problem, no issues. Clear to everyone? Okay, next question. Now be careful about this. Karthik, alternate signs were there, na? Positive, negative, positive for the different ranges. So that's how we wanted to have a positive value. Okay, types of brackets. Some people are confused about that. Let me just recall. If we are having these round brackets, so a comma b, it gives us a range from a to b, excluding the boundary values, right? If x belongs to a comma b with this round bracket, so it means x can be anything from a up to b, excluding the boundary values. But if we use the square brackets, it means it is again a range of values from a to b, including the boundary values. But if there's third type of bracket also, which we call sometimes curly brackets. Now this is not a range, it only gives the two values. It only gives the two values. This is a set of values. It's not range, it is a set of values. The values are a and b only, two values only. So these are the three different types of brackets. Fine, so those who are confused about the brackets. Okay, I have started to get the correct answers here. Good. See, the important point in this question is that, please tell me, can we cancel out x minus 1 on both sides? I can see a common term here, x minus 1, x minus 1. Can we cancel this x minus 1 on both sides? Satyajit, this is a similar question. It's a similar question. If there's any doubt in the last question, please focus here. That will be clear. Can we cancel this x minus 1, the common term on both sides? Some of you are saying yes, some of you are saying no. So the answer is no. I repeat, the answer is no. We cannot cancel out the common term here because this common term is a variable. It includes a variable. I repeat, because this common term which we are seeing here x minus 1, it is a common term, there's no doubt about it, but we cannot cancel it because it contains a variable. Okay? So then what to do? How to do? So how to do? So what we need to do is bring this RHS. Let's bring this RHS on the left hand side. So it comes out to be x minus 1 into 3x plus 2. And that term when we are taking on the left hand side will become with negative sign. So negative of x minus 1 into 2x minus 5. And that should be greater than equal to 0. Till this step it is okay? Is it fine? No, we cannot divide with variable also. Whenever we are having variables, so it's always better to make one side 0. And to make it 0, we just need to transpose this RHS on the LHS as we have done. Fine, this step is clear. Now what we can do, among these two terms, we can take this common x minus 1 outside. Right, now we can take common, which is x minus 1. And what is remaining now? This is 3x plus 2. And with minus sign, we have this 2x minus 5, which we want to be greater than equal to 0. Is it fine? Okay, now it is very simple. It is x minus 1 into this will be 3x plus 2 minus 2x will make it x, and plus 2 and plus 5 will make it 7. So x minus 1 to x plus 7 is greater than equal to 0. So that is the final inequality which we have to deal with. Fine. So that is the inequality which we have to deal with. And now you can very easily see the critical point is plus 1 and minus 7. So this is minus 7 and this is plus 1. So again, this upward parabola, this part is positive here, negative here, positive here. And we are looking for the positive values. We are looking for the positive range. Right, so we are looking for the positive range. So it is more than 1 and less than minus 7. So that is the answer. So as we wrote earlier, so minus infinity to minus 7, including the boundary value, union 1 to infinity. So this is our answer. Is it okay? So don't quickly write minus 7 to 1. Minus 7, minus 7 and 1 are the critical points here. So but what range will satisfy here, that we need to see. So our requirement here is that expression must be greater than or equal to 0. That means it should be positive or 0. So these extreme ones are the required answer. Is it fine? See, what would have happened if you directly cancel x minus 1? If you directly cancel x minus 1, in that case you will be getting incomplete answer. In that case you will be getting incomplete answer. Okay, Shrimi is asking why we have included the boundary values. Because of this equality, sir or ma'am. This is greater than equal to 0. That means this expression can be equal to 0 also. So this can be equal to 0 also. So because it can be equal to 0, that means I can take x to be equal to 1 also. I can take x to be equal to minus 7 also. That's why. Is it fine? Upward parabola kaise ho raha hai bhai? Who is that? Thank you, Priyanka is answering. And Dipanshu. The leading coefficient was positive. And I have also told you, even if you don't remember that, we can check the values. If I take x to be more than 1, whether this value is going to be positive or negative, that you can check now. Okay, let's move further now. There are a lot more many things to be covered. So now three terms here. There's a good question. Pritam is asking why we exclude infinity. I was including that 1 or minus 1 or 7 there. But why we are excluding infinity? Because infinity is not considered as a real number. That's why I answered that earlier also. Somebody was asking. So infinity is not considered a real number. That's why we put that round bracket with infinity always. ठीक है? Answer तो यही है सत्यजीत. If you take them separately, then answer तो वही आने वाला है. But it's going to take long time, and you may miss some cases also. So please don't do that. Isha is asking, will the range always consider infinity? It depends upon the value which we are looking for. In the last question, if it would have asked for the negative expression, then -1 to -7 to 1 के बीच वाली value आने वाली थी ना? Okay, in this question now there are 3 terms. So can you tell me what are the critical points here? What are the 3 critical points here on the number line? What are the 3 critical points here in this question? Okay, most of you are getting the answers. Nice, very nice. The 3 critical points here are -7, 2 and 9. ठीक है ना? -7, 2 and 9. Let's, maybe they are somewhere here. Fine. Now, as I said, I don't know what about the coefficient, leading coefficient here, and the first part, this will be positive or negative. Let's check. So if I take the value of x to be more than 9, what happens? If I take value of x more than 9, so more than 9, this term will be positive. More than 9, this term is also positive, and this is also positive, and the product will also become positive. That's it. So in this range, when x is more than 9, the right hand value, the region is going to be positive always, and this region will give us the negative values. This will again give positive, and this will again give negative. So graph, if you are going to make, will be something like this. It will go like this and this and this. ठीक है ना? The graph will be something like this. Anyway, so we wanted to have the value greater than or equal to 0. So equality is there, so we can include the critical points, and because we are looking at the positive expression, so positive values will be determined, will be obtained in this particular region and this one. Right? So that's going to be our answer. That is -7 to 2, including the boundary values, and this one 9 to infinity. So that is the required answer for this particular question. That's true, right? Excellent. Is it fine? Okay, let's quickly move to the next one. Here's one more similar question. Please answer this. This is the last question of this type. There are a few more questions that you can take screenshot and solve later. Then we are having a lot more thing to cover. We have to cover the maximum minimum part. Critical points here, it's -8, 1 and 3. And again, if you will check, you will find the same region here. This is positive region, this is negative, positive and negative. And this time we want it to be less than or equal to 0. So these two are the required regions. Fine. So -8, minus infinity to -8, and then 1 to 3. Excellent. Yes, that's true. Most of you are writing it correctly. Fine. I hope it is clear to all of the students who are watching it live right now. Good. कार्तिक, नेगेटिव कब आएगा? कौन सा नेगेटिव कब आएगा भाई? Please be specific. I didn't understand your question clearly, Karthik, if there's some doubt. Okay. See, we wanted to have less than equal to 0 negative region. So negative region, this one is there and this one is there. And this is the region minus infinity to -8. So -8 is included. Infinity is never included. I have just discussed that. So that's why I'm using this round bracket. And with union, we'll have this range 1, 2, 3, including the boundary values. That's our answer. Pritham is asking how to know positive and negative region in 3 points. By checking the values, Pritham. See, I just checked that here also. If the value of x is more than 3, take the value of x to be more than 3. So put it here. If x is more than 3, this term will be positive or negative. Everyone tell me. If x is more than 3, anything you can take. So this is going to be positive, na? And this is also going to be positive. This is also going to be positive. And the product is also going to be positive. That's it. ठीक है? Yes, easiest है. Value लेके देखो. Why to remember? You will forget. The point is that if you will remember, you will forget. So don't remember. No need to remember. Understand. Try to understand. ठीक है? Okay. I shall move further now. That's an easy question. If you want to answer, please answer it fast. Please answer it fast. So critical points here on the number line, -4, -2, 1 and 2. So as always, this is always going to be positive, more than 2, positive, 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 positive. This is positive, this is negative, again positive, and again negative, and again positive. And we are looking for the range less than equal to 0. Good. So -4 to -2, including boundary values because equality is there. And then we are having 1 to 2. Good. Good. It's very pleasing to see the right answers on the screen. Janvi, I think you typed wrongly. Anyway, I hope you have understood the idea. Okay, here's one slight tricky part here. Can you answer this? x plus 8, x minus 1, x minus 3 whole square is less than or equal to 0. अरे easy ही है यश, I have already told that. I always told that. It's not difficult. Difficulty is till that point when you think, अरे ये भी याद करना पड़ेगा, अरे ये भी याद करना पड़ेगा, अरे ये भी याद करना पड़ेगा. Then it becomes difficult. But if you try to understand the things, they are not difficult. Okay, what are the critical points in this case? Okay, Kavya has come up with the answer. Good. Tanishk is saying 3. 3 लेना है क्या? Should we consider 3 here? No. See, if I take x to be 3, it's possible, right? Because it will become 0, no problem. If I take x to be more than 3, so because it is a square number, it is always going to be positive, right? If I take x to be less than 3, then also it is not going to make any change. So basically, 3 is not a critical point here. 3 is not a critical point here. So the value which you are looking for less than or equal to 0, it only depends on these two. ठीक है ना? So 3 has no particular role here. Because this value is always going to be 0 or more than that. 0 or a positive number. Right? So this the remaining expression should be less than or equal to 0. So that's the requirement. So minus 8 and 1 are the critical points. The value is positive here, negative here, positive here. And because we are looking for the negative part, so minus 8 to 1 is the right answer. Including 3. Right? In addition to this, we need to take the value 3 as well. Okay? That is the only use of 3 in this case. So we can take x to be 3. Right? The answer will be minus 8 to 1, including the boundary values, union 3. X can be equal to 3. We cancel the third term because what should I say? So we cancel the third term because we said this is not a critical point anymore. Sign change doesn't happen, is not happening here. But this point 3 will be used. I can take the value of x to be 3. So this is to be included here. This is to be included here. So we should not miss that point. 3 is to be included here. The value can be 3, but sign change point will not be there. ठीक है ना? Okay. Again, similar expression. So we need to consider this minus 4, 1 like that. But the even powers can be negated. Even powers can be left. Because equality is there. So we can take the critical value of these points here. X can be taken as minus 4, that will work. X can be taken as 1, that will work. X can be taken as minus 2, or X can be taken as plus 2. So but even powers can be discarded. Even powers can be discarded. So what is remaining here is actually is x minus 2 into x plus 2. That product should be greater than or equal to 0. Is it not? So on number line, this minus 2 and 2 greater than or equal to 0 is what we are looking for. So this is a positive region, negative region, and positive region. So of course more than 2 and less than minus 2, and including these values minus 4 as well as 1. Curly bracket I told you in the previous one of the previous slides. The curly bracket gives us the specific values only. That gives us a set. These two brackets gives us the range. They give us the range, and this curly brackets gives set of values. Okay? These two brackets gives us a range of values from this to this, excluding or including, and this curly brackets gives us a set of values, whatever values are there. Fine. Okay. I think that's sufficient for this part now. So the next question you can take a screenshot. We are not going to discuss it now. You can take a screenshot. There are again similar questions. This one, or you can take a screenshot later as well if you wish. We can discard the even powers, Jafar, and whatever is the exact power, that is not required. That's not required. Because we are just taking into consideration the sign change of the expression. Only that's what we are considering here. Okay? So this is one question as your homework, and this question is also for your homework. Right? This question is also for your homework. You can take screenshot for this, or you can take screenshot later as well. It's your choice. I'm moving further. Okay, next, the last important part of today's part. Piछले section वाला question that will be discussed now. That question will be discussed now after doing this part. The one question remaining which you have to discuss with the alternate method of maximum minimum value, that will be done after this part. So first, that's why I reached here. So this is famous inequality relation. There is one very famous inequality which is known as arithmetic mean is always greater than or equal to geometric mean. This is a special inequality. There are many more such special inequalities, but right now we will be focusing only on this part, that AM is greater than or equal to GM. AM is arithmetic mean and GM is geometric mean, and this is true for positive real numbers. Fine. This is true for positive real numbers. Not less than. Ulta hoga. Are? Okay, let's check. Some of you are having doubts. Ulta hoga kya? Okay, let's see. Let's check. Okay, let's consider for two real numbers A and B. Can you tell me what is the arithmetic mean of A and B? For two real numbers, it is A plus B by 2. Fine. So it is A plus B by 2. Right? There's no difficulty in that. Let's check. Some of you are having doubt कि ये sign ulta होगा क्या? Let's see. Let's check out. So arithmetic mean of two real numbers A and B is A plus B by 2. And what is the geometric mean? What is the geometric mean of A and B? It is a root of that, a root of A and B, right? It is square root of product A into B. Is it okay? Right, that's true. Ashu has found the sign. right? Root AB. Okay, so right now you are confused about this sign. This sign is right or not? Okay, let's keep a comma here. I'm not sure. Okay, let's leave it. Okay, Gunjan ne yaad kiya formula. Anyway, so I'm leaving it comma here right now. So if I take 2 that side, it comes out to be a plus b, comma root of twice of root of AB. Fine. Okay, because this is a constant number, so we can cross multiply. There's no issue in that. And now transposing this part on the left hand side, we'll be having a plus b minus twice of root AB. We are comparing it with 0. That's what we need to see. Fine. Now, can you identify this expression, this identity? It is root a minus root b whole square, isn't it? This is root a minus root b whole square. A plus b minus twice of root ab, isn't it? And we are comparing it with 0. Can you tell me this value is going to be less than 0 or greater than 0? It is going to be greater than or equal to 0, provided a and b both are real numbers, positive real numbers, right? So if a and b are positive real numbers, that is an important condition here. They must be positive real numbers. So in that case, this expression is going to be 0 or more than 0. So that's why the initial expression, initial sign which we wrote was certainly correct. And as in Gunjan extended this idea, and that's true basically, is greater than or equal to HM also. And if you're going to extend Gunjan, so let me tell you one more thing. RMS is greater than or equal to AM also. Anyhow, I'm not focusing on these 2 terms right now, but if Gunjan is extending something, so I should also, so bhai, I'm also experienced one. I can extend it further also. So anyway, right now we are focusing on this part as arithmetic mean is greater than or equal to geometric mean for positive real numbers. RMS is a root mean square value. RMS is root mean square value. HM is harmonic mean. RMS, I just told you, it's a root mean square value. Leave it for now. Leave it for the time being. We are not going to discuss it. गुंजन जी जिस स्कूल में आप पढ़ रही हैं, हम पढ़ाने वालों को पढ़ा चुके हैं, बहुत साल हो गए हैं. Anyway, not Reliance Mobile Services. It's a root mean square. Anyway, let's focus here. So the point here was arithmetic mean is greater than or equal to geometric mean. This is the most important identity which has been used in all of our entrance exams. And not directly, not mathematically, just in terms of these values. See, a plus b includes the sum of the terms, and a into b includes the product of the terms. So what we can infer from here, that a plus b, this 2 is a constant value. So if a plus b is constant, if sum is constant, let me write it again. A plus b by 2, we have just got it is greater than or equal to root of ab, right? So now this a plus b is sum of the numbers, right? So if this sum is constant, let's say if sum is constant, if a plus b is constant, if the sum is constant, then what is going to happen? If the sum is constant, then this product a into b will be less than or equal to some constant value, is it not? Please listen carefully, students. Bhai, kahan pahunch gaye? German, electrical. Come back here. A plus b by 2 is greater than or equal to ab. So if a plus b is constant, so this total value becomes constant. So if sum is constant, in that case this product is going to be less than or equal to some constant value. So this product will be maximum when it will be equal to this. And when this equality is going to occur, see here, when this equality will be here, when the terms a and b were equal to each other. I repeat, please see it very carefully. So when the terms are equal to each other, in that case, this product will be maximized. So that is the basic idea which we are taking from this inequality, that if sum of some positive real numbers is constant, in that case, product will be maximized by making the terms equal. Okay, by making the terms equal. And why we are taking equal, that suggestion we can get from here. Okay, this will become equal to 0 only if a and b are equal. Fine, so right now we are discussing only, we are use it only for 2 terms. It can be more than 2 terms as well. It can be more than 2 terms as well, right? So this is the first conclusion. If a plus b is constant, if sum is constant, right? And the second condition is if this product is constant, if a into b is constant. If this product is constant, what is going to happen? This is 2 times this product, that will be constant value. Then a plus b's sum will be more than or equal to a constant value. I repeat, please ध्यान से सुनिए. So this product will be constant. If a into b is constant, in that case, this 2 times constant value is a constant number. So this sum will be greater than or equal to this constant value. That means the minimum value of sum will be minimized when it becomes equal to that constant value, right? So this sum will be minimized by making the terms equal. So these are the 2 important conclusions which we derive from this famous inequality AMGM. इसको AMGM equality भी short में से बोल देते हैं. So these same 2 conclusions you will find on this next screen now. If sum of all the terms is constant, then the product will have its maximum value if all the terms become equal to each other. Fine. And same way, if product of all the terms is equal, then sum will have its minimum when all the terms become equal. Okay, now let's try to understand it with some examples. Okay, if I give you x plus y, the first case is sum of the terms is constant, so I'm taking 2 example terms only. If x plus y is equal to 10, where x and y are real numbers greater than 0, they belong to positive real numbers. Okay, x and y are positive real numbers. Fine. So if x plus y is equal to 0, so my question to you is the value of x into y, maximum value of x into y, what it will be? Can you think of what will be maximum value of x into y? We are taking example, Rashna, don't worry. Okay, Anurag says 25. How do you know it is maximum? How are we getting it? We have to just make the terms equal, right? See, some of you may doubt while we are trying to make the terms equal, how do we get to know that this is the maximum value? Can't we get more than this? Yes, we have done the equal distribution here. So we need to make them equal as much as possible. As somebody wrote, as close as possible. That's true. If it is mentioned they are integers, let's take in this case x and y. Suppose they are positive integers. Right now, let's take them there to be natural numbers. Let's assume that x and y are natural numbers. So what could have been the value of x and y? So minimum value of x could have been 1. So if x is 1, then y would have become 9. So the product will become 1 multiplied with 9. That is 9. Right? I'm taking an example that x and y are natural numbers right now. Okay? So if x is 1, then y becomes 9. The product becomes 9. What is the next value possible? So x can be 2. So if x is 2, then what will be the value of y? Y will become 8 now. And the product comes out to be 16. You can see that it is increasing, right? And further, if I move to take x3, then y becomes 7, product becomes 21. It is further increasing. So as the two values of x and y are coming closer to each other, we can see when it becomes 4 and this one is 6. So it is further increasing. So it becomes maximum, they become equal to each other. Because after that, again, the values, the product is going to decrease. Is it fine? So that's how the direct portion was that. If sum of the two positive real numbers is constant, the product will become maximum when both of them becomes equal. That is 5 each. So that's how we got our answer, 5 into 5. Is it fine? So 5 multiplied by 5 is 25. Chicken, it's not root 25. Okay, is it fine? Okay, let's answer one more question here. If I give you the values as say x plus y plus z equals 12, and suppose x, y, z are natural numbers only, can you tell me the maximum value of x into y into z? Maximum. What can be maximum value of x into y into z? Please answer. Not 6, Shubh. I think you missed right. 64 is right. Good. Excellent. Okay, a better question. A better question now. If I ask you, what would be the maximum value of x minus 1 into y minus 1 into z minus 1? Now answer. Can you answer this one now? X minus 1 into y minus 1 into z minus 1. What would be this maximum value? That's true. Subhajit, Aditya, good. 27 is correct. Excellent, Zinab. Shubhangi, Shubhangi सही बोल रही है क्या? अरे, no, Shubhangi, you have done some mistake. Okay, see now, in the previous part what we did, these are three numbers, all three are natural numbers, their sum is constant, so we want to maximize this product. So this product will be maximized if the sum of these terms is constant, and sum of these terms is 12, it's constant, so each term must be equal, that is 4 each. So 4 multiplied by 4 multiplied by 4, that was equal to 64. Wonderful, right? Exactly same way, we want to maximize product of these three terms. Now first see whether sum of these three terms is constant or not. Is the sum of these three terms constant? Yes, let's check. Sum of these three terms, x minus 1 plus y minus 1 plus z minus 1 is nothing but x plus y plus z, that is 12 minus 3. That is 9. So sum of these three terms is constant. So their product will become maximum when each terms become equal. That was our idea. If sum is constant, then product will have its maximum value if all the terms are equal. That was the whole idea. So here, sum of these three terms is constant. It is 9. Isn't it? Because sum is constant, in that case, the product can be maximized by making all of them equal. Equal to how much? 9 by 3, 3 each. That comes out to be 3 into 3 into 3. That is 27. Is it okay? Priyanka, I am just following this statement only. The terms whose product we want to maximize, it can be done provided their sum is constant. So first check, is their sum constant? We have just done that. Yes, their sum is constant. How do I get to know? It is x plus y plus z minus 3, which is 12 minus 3, that is 9. So sum is constant, so product will be maximized by making each of the terms equal. That is 3 into 3 into 3, 27. Yes, cutting cube may be similar, exactly. That's true. Okay, I hope this idea is clear to all of you. Let's answer one more question in the same data. Can you tell me the maximum value of x minus 1 into y minus 2 into z minus 3? What will be the maximum value for this expression? What will be maximum value for this expression? Akshat, just 5-10 more minutes. अरे तो 9 भी नहीं बजे. Eight is the correct answer, not 6, Ashar. 8. We have to multiply those values. Deep likha ho. Arey Baba, sum of these three terms, please tell me whether it is constant or not. Sum of these three terms, is it constant? Yes, it is. How much it is? Eight is the right answer. Sum is constant, and what is that constant sum? The sum is this x plus y plus z minus 6, that is 12 minus 6. Sum is 6. right? Sum is 6. So because sum is a constant value for these three terms, so their product will become maximum if each of the terms become equal to each other, that is 2 each. So the answer comes out to be 2 into 2 into 2, that is 8. So this is the right answer. ठीक है? Yes, that's true or no? Okay, and similarly the other property was that if product is constant, if product of all the term is not equal, it should be constant. If product is constant, then sum will have its minimum value if all the terms become equal to each other. Just opposite of this. Just opposite of this. So let's take a simple example. If it is given that x into y equals 100, for simplicity, let's take x and y to be natural numbers only. So can you tell me the value of, minimum value of x plus y, please? What can be minimum value of x plus y? 20. Yes, Shubh. Shubh, it is not 10. It is 10 plus 10. That is 20. Good. All of you have understood. Nice. Clear? That was a simple example. Again, we can extend this idea to further varieties, but that was the basic thing. So if the term whose sum we want to minimize, we need to see whether their product is constant or not. And yes, their product is constant because x into y is given equal to 100, right? Because their product is constant, so sum will be minimized when both the terms are equal. So if x and y both are to be equal such that their product is 100, their product is 100, so of course each of them must be equal to 10 each. So 10 plus 10 makes it 20. Okay, another one. Now answer this. What can be the minimum value of 4x plus y? Can you think of this? Minimum value of 4x plus y. Now be a little careful. What can be the minimum value of 4x plus y? Sanskriti, that's not correct. 40 is the right answer. Harsh, Jokania, jeete hain. Not 7 crore, but anyway. 40 is the right answer. Good. See, we are not to put the value of x and y has to be 10 always. Kuch bhi puch le 10 put kar do. No. What we have to see is that this sum we want to minimize. First see whether this product is constant or not. So let's check 4x multiplied by y. That is 4xy. What will be this product? Is it constant or not? It is equal to 4 times 100. That is 400. Isn't it? This product is constant. It is 400. So because now this product is constant, so these terms sum can be minimized by making both of them equal. That is 20 each. So it is 20 into 20. So the required sum is nothing but 20 plus 20. That is 40. In the previous case, we took x and y both to be 10 each, so that was 10 plus 10, 20. But in this case, y is 20 and x comes out to be 5. Okay, so don't do this casual errors. Don't do these casual errors. Okay, so there are a few questions for you as homework. So here are them. You can take screenshot. They're very easy questions. Let's do this one question together. It is asking ABC are positive real numbers, then what will be the least value of this expression? See, at the first look, this expression may look a little scary. It may look a little scary, but it is not that scary. So what to do? Let's separate them out. I'm writing it for you. AB into A plus B upon ABC plus, I'm just separating out the three terms. So it is BC into B plus C upon ABC plus CA into C plus A upon ABC. Right? So whatever terms can be cancelled, let's cancel them. AB cancelled, BC cancelled, CA and this AC that will be cancelled. And now dividing this, we can write the expression as it is A by C plus B by C. Right? And the next one would be B by A with positive sign, B by A plus C by A, and finally C by B plus A by B. Oh, so this is the expression. Now, it is sum of the sixth fraction. Question is asking about what will be the least value or basically minimum value of this expression. And they are all positive real numbers that is given. So if they are positive real numbers and we want to find the minimum value of this sum. So what was the idea? So we can find the minimum value of the sum provided their product is constant. Please check whether their product is constant or not. What is their product? Can you see? Product was not mentioned anywhere in the question, but anyway, can we find this product? Is it coming out to be constant? Ashish, after that is the last part now. First answer this one. Yes, this product is coming out to be 1. It's a constant value, right? In the numerator part, I can see A 2 times, in the denominator A 2 times. That will be cancelled. Same way B and denominator also B, numerator C, denominator also C. So the product of these 6 terms is constant. It is 1. So there it is constant value. So this sum can be minimized if each terms become equal. That is equal to 1 each. So that's how 1 plus 1 plus 1 plus 1 plus 1 plus 1. That comes out to be 6. So that is the minimum value of this expression. Fine. Okay, there is one more way to answer this question, that is using the symmetrical expressions phenomena. Symmetrical expression, or sometimes it is also known as cyclic expression. What is the meaning of the symmetrical expression or cyclic expression? See, symmetrical expression means in this expression we are seeing the 3 variables A, B and C all are appearing equally and in similar manner, symmetrical manner, right? All A, B, C are appearing in symmetrical manner, or we can also call it cyclic. Means if I replace all the A's by B's, replace all the B by C and replace all the C by A, the expression does not change. right? Expression does not change. So that is called a cyclic expression. So if by changing all the variables cyclically, A to B, B to C, C to A, the expression does not change, so this is called a cyclic expression. So this type of symmetric expression or cyclic expression achieves its extreme value when all of them are equal. That's it. So if we put all of them to be equal, we'll get our answer, and that's what finally basically we have done. Okay, so let's come back to that our actual question now, which we were discussing in the last section. By the way, here are 2-3 questions which you can take screenshot. You can take screenshot of these questions. Here's a question on your screen based on this idea we have just discussed. You can answer them later as your homework. Okay, and there's one more. Bhaskar, we just discussed about cyclic expression. If the expression is a cyclic expression or symmetric expression, in that case, when all the variables become equal, in that case, we get one extreme value. That's the thing which we discussed. Okay, I'm coming back to the question which we were about to discuss again using this maximum minimum method. So here it is. Let's solve it now. The question was, if you remember, it was x square minus x plus 1 upon x square plus x plus 1, right? This was the expression whose maximum minimum values we were supposed to find. Yes, this is the last question now. Shriram is asking the last question, please. You can check it again also in that video, isn't it? Okay, this is here. It's here. Okay, I was worried. Anyway, so this was the question, x square minus x plus 1 upon x square plus x plus 1. For this expression, we were supposed to find minimum and maximum value, right? And x is a real number here. But see, x is not positive mentioned here. X is not positive mentioned here in this question. Okay, so how to solve this question in a better way? That's the basic idea now. But before covering this, let me ask you one more simple question. If it is, we have to find minimum value for x plus 1 by x. Can you think of this? What will be the minimum value for this expression? What will be minimum value for this expression? Yes, it's 2. That's fine. That's very nice. So because their product is constant, the product comes out to be 1. So sum will be minimized when both terms are equal, 1 and 1 each. So, and this is true only for positive real numbers. If positive real numbers condition is not there, it is not the condition of positive real numbers. In that case, can you find its maximum value also? If x can be negative also in that case, this is for positive part. If x is positive, in that case the minimum value comes out to be 2. If x is negative, let's say if it is given that x is negative, in that case what will happen? We can just put some values and check. If x is negative, in that case, at x equals minus 1, we are going to get the maximum value. That will be minus 2. Yes, minus 2 will be the maximum value if x is negative here. Okay? Just remember these 2 points and let's come to this question. So this expression can be rearranged like this. It is x square plus x plus 1 minus 2x upon x square plus x plus 1. Okay? Yes or no? Now, this part is completely divisible. It comes out to be 1 minus 2x upon x square plus x plus 1. Fine. So now it comes out to be 1 minus, if I divide by x throughout, because x cannot be equal to 0, of course. We can't take taking x not to be equal to 0, so we can divide by x. So it comes out to be 1 minus 2 upon x plus 1 plus 1 upon x. Fine. It's 1 minus 2 upon x plus 1 plus 1 upon x. Now taking the two cases, x is positive or x is negative. So if x is positive, then x plus 1 by x will have its minimum value of 2. Right, minimum value of 2, and then 2 plus 1 will make it 3. That's the minimum value, right? If this is the minimum value of the denominator, so this is the maximum value of this fraction, right? So 2 by 3 is the maximum value of the fraction. That makes it the minimum value of the complete expression. So 1 minus 2 by 3 will give you 1 by 3. So 1 by 3 is the minimum value. Let me repeat. So x plus 1 by x minimum value would be 2. So 2 plus 1 makes it 3. 3 is the minimum value of this denominator, which means 2 by 3 is the maximum value of this fraction. Right, which makes 1 minus 2 by 3, that is 1 by 3 as the minimum value of the complete expression. That's the answer. Second part, if x can become negative, in that case x plus 1 by x, so maximum value was minus 2, isn't it? It was minus 2. So x plus 1 by x comes out to be minus 2. Minus 2 plus 1 makes it minus 1. So minus 1 is the maximum value here, right? Minus 1 is the maximum value here. So this minus 2 upon minus 1 makes it plus 2. Now this is the maximum value of the total expression. Now so 1 plus 2, that will make it 3. So 3 is the maximum value of the expression. So that's how also we could have limit the values. Okay? Minus 2 we have just calculated this, Rashna. If we take x to be negative, in that case the value of the expression is going to be minus 2 or less than that. Value of the expression will be going to be minus 2 or less than that. We can check the values. Okay? So let's stop here for the day. We have discussed all the topics which we were supposed to, and in between we have taken 3-4 screenshots as well. You can solve the questions, practice. Thank you very much. So that's for the day, and tomorrow we shall discuss about the modulus part. Okay? Thank you. Good night, everyone. Thank you. Yes, the topic is good. Questions are also good, and you also are. You all are also very good. Your participation is good. Thank you. Thank you, Raghavendra, Sanskriti, Pratishtha. Bye everyone. Kanishk, Shilpi, Darshan. See, I can't see all of you here, but just by speaking up your names, that looks like that I'm talking to you only. So that gives some personal connect. Okay, thank you, Priyanka. आपको मजा आया? Good. Okay, so I shall end this live chat now. Thank you. हाँ जी दिव्यराज, खत्म हो ही गया. आशु मॉडुलस के नॉन लीनियर वीडियो 2 बार देखे फिर भी नहीं समझ में आया. डोंट वरी, वी शैल डिस्कस टुमारो. आकृति, यू डिडंट आंसर माय क्वेरी. क्या क्वेरी थी बाबा? आई फॉरगॉट. प्लीज यू कैन स्पीक अप नाउ. आई एम स्टिल अवेलेबल. Tulika, you can certainly get a good start with today's session. Integral solutions की live class होगी. What is that? If we get some time in between, so you can ask the questions. I will try to answer. I think we discussed about integral solutions earlier, na? Linear equations part. But if there are some particular doubts, you can ask. We can discuss that. Akriti, I'm waiting for your query. Or you can post in the group as well. There's no difficulty. Okay, I'm waiting, Akriti. If anyone else wish to ask something or say something? I thought to take up your doubts today, but somehow. And that's true, Satyajit. 3x plus 2 when you're taking greater than or equal to 0, so that will give you x greater than minus 2 by 3. Okay. Anjul, I've just answered that. You can ask the questions. There's no separate topic for that. I don't know which question are you asking, so you can ask the questions and then we can discuss whatever the concepts are. Satyajit Baba, we need to take up the common solution. It's not that just 3x plus 2 must be greater than or equal to 0. X minus 1 should also be greater than or equal to 0, na? Both things should satisfy, isn't it? Both things should satisfy. That's what we have to see. Okay, Akriti is asking how many real solutions. Acha, she asked in between. How many real solutions does the equation have? 2x square minus 5 by 3, x square minus 3x equals 1. It's difficult to behold it. Is it in denominator? 2x square bracketed part के बाद जो लिखा है वो कैसा है? Is it in denominator? 2x square minus 5. Acha, I think you're asking this 2x square minus 5 divided by 3x square minus 3x. Is it so? I'm not sure. I think you can post this question in the group, Akriti. Someone from iQuanta team can help you. Second part is in power. Okay, Asha, this is in power. Okay. 2x square minus, is it 5 by 3? I got it. See, you are talking something like this. M raised to power n equals 1. M is a quadratic expression, n is also a quadratic expression. Is it in the case? That's the case, na? Please confirm. You are asking something about like this. M raised to power n equals 1. M is a quadratic expression, n is also a quadratic expression. Hai na? Okay, now can you think of what can be the value of m so that it doesn't depend on n at all? M can be 1. So then 1 raised to any power will always be ending in 1. That's the one case. Okay? So make this m equals to 1 and you will find the values of x. Okay? And there is no limit on the powers of the values of n. N can be negative or 0, positive, whatever it may be. Next case, if this power becomes equal to 0, if this n becomes equal to 0, then m power 0 is also equal to 1. That is the second situation. So in that case, you need to put n equals to 0 and then find the values of x. Only thing you need to take care about is this m should not become equal to 0. And the third and final case is that if this m is minus 1 and this n becomes even, then also the value comes out to be 1. So you need to put m equals minus 1, find the values of x, and at those values of x, check whether n comes out to be even or not. If it doesn't come out, then there is no solution. If it comes out, then there also you will get some more solutions. So these are the three particular cases you are to check. Is it fine? Yes, Aditya has mentioned that. So 1 power anything, m power 0 or minus 1 power even. Good. Okay, so let's end for the day. Thank you everyone. Thank you Akriti for the nice question, and I'm happy that you have got something here. Thank you.